This is chapter 7, section 1. We're dealing with proportions. Okay? Yeah, in your journal. So what I want you guys to do is I want you guys to write the definition. Proportions are basically two equal ratios. For example, if I have a ratio of 1 to 2, that's going to equal the same ratio as 4 to 8, which is the same as 6 to 12. So these right here, what is a ratio? A ratio is a comparison of two numbers. What am I comparing? 1 to 2, 4 to 8. That's what a ratio is. Now this can also be rewritten as what? 1 to 2, 4 to 8, 6 to 12. Even though you can't see it, what does that little colon right there represent? The word 2. That saves me from having to write 1 to 2, 4 to 8, or 6 to 12. That saves me from having to write all that. Now, something that's interesting about all equal ratios is their cross products are always equal. Look at these cross products. What are these cross products right here equal to? 2 times 4 is 8. 1 times 8 is 8. Those cross products are equal. I'm going to change colors. Look at those cross products right there. What's 4 times 12? What's 8 times 6? Boom. Interesting. Even if you did it like this, watch. What are these cross products right here? 8. Same way. Understand, in a proportion, when you have two equal ratios, the cross products are always equal to each other. So right now, we're going to create a ratio in this classroom. We're going to create a ratio. We are going to compare the girls to the boys. That's what we're going to compare. So we're going to go around the room. I have 1, 2, 3. We only have 3 because Katie's not here, so we only have 3.
Let's count Katie.
Over there. All right. I think boys we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right. So you know what? To make it a little bit easier, let's take me out of the equation. Let's say in the classroom we have 3 to what? 3 to 12. So that's a ratio between the girls to the boys. All right. Now we always, if we can, we always want to simplify it if we can. All right.
That's a 1 to 4 ratio.
That's a 1 to 4 ratio. So here's what I want you to do. Put right 1 to 4. Now this ratio right here can also be written as 1 over 4. Yeah, absolutely. Write it down. If we're practicing right now in your journal, we're practicing. You have a better concept of how to set up ratios and proportions correctly. What I do is I always label stuff. So I never just put 1 to 4. I always write, oh, wait a second. This right here, this number 1 represents the number of girls. This 4 represents the number of boys, so I don't forget what I'm comparing. So 1 to 4. So let's think about this. What if I said, all right, what if I said there were 100 boys at our school? All right?
We need bigger school.
Well, if we have 100 boys,
1 out of 5.
1 out of 4. So what would you have to do to multiply 4 times what gets me to a 25? 25. So I would do 1 times 25, and that would tell us that we would have what? 25 girls. So I want you to understand, did I cross multiply that time?
No.
No. So understand, you don't always have to cross multiply. There are different methods to be able to solve the ratio. So what did I do? 1 over 4 equals 25 over 100. So let's review. What did I do? I said 4 times what is 100? I said 4 times 25 is 100. So I did 1 times 25 is 25. So you don't always have to do what? cross multiplication.
If it's like that, you just think quarters.
Yeah, you can think of quarters. It makes it easy. Now, understand, if I did it the cross multiplication way, I'm going to put x over x. So let's say you couldn't do it that way. Let's say you wanted to solve it through cross multiplication. Then you could do the cross products. Now, what are my cross products right here?
4x equals 1 times.
4 times x is 4x. 1 times 100 is 100. And then you would have to divide both sides by...
And then it would equal 25.
That still gets you 25, right? So there's more than one way to do it. I'm not sure how your brain works. I need you to find the way that works not 9 out of 10 times, but what works 10 out of 10 times. Okay? So what we're going to do is I'm going to pose a question to you guys right now. So I'm going to pose a question, and we're going to go back up to our original ratio, okay? Which was what? A 1 to 4 ratio. So what I'd like you to do in your journal, write 1 to 4, and please label this as your girls to boys. And what I'd like you to do is I would like you to create a ratio. Here's the ratio I want you to create. So on your paper right now, create a ratio, a simplified ratio of girls to total students. All right, let's check this out. So right now, if you wanted to do a ratio of girls to total students, hopefully you guys put 1 to 5. Now, why in the world would I do 1 to 5? Well, if I have 1 girl and 4 boys, that means there's a total of 5 total students. All right, these are questions that could be posed of you on some type of standardized test, which tests you about ratios of proportions. So, by the way, what would I say right here? What would be the percentage of girls to the total population? What would be the percentage? If I said, what's the percentage of girls to the total population? What percentage do you think they would be? 20%, that's right, good. It's a 1 to 5, which is what? Which that's equal to the decimal of 0.20, which also is the decimal of the percentage equivalent to 20%.
I thought you were talking about like the actual.
No. Like I'm just using these two ratios. Yeah, hypothetically right now. And what, by the way, would you agree right now in our class we have a 3 to 12 ratio? So what percentage is 3 to 12? Well, the total it'd be 3 to 15. So you're right. It is still equal what? 20%. Okay. So if there's 3 girls and 12 guys, then it's still a what? 3 to 15 if you're comparing the total numbers. Okay. Now, when are you going to use ratios and proportions? Whenever you can do that in the real world.
Like all the time.
All the time. When you guys go to Walmart, what are you guys going to look at? You're going to look at the price per unit, the price per ounce, the price per pound. All of that. So right now, what I'd like you to do, we're going to go ahead and work through number 2. Since we didn't do number 1 on the video, we're going to do number 2 together, all right? And then I'm going to see if you guys can solve number 3 on your own. So right now, problem number 2, what I'd like you guys to do is solve this using cross products. I feel that's probably the easiest method right here. So we're going to set up our cross products. One of them is 7 times the difference of 3 times the number and 5. And the other cross product is going to be a 4 times a negative 5. So I'm going to let you guys go ahead and work that out, see what you come up with. We'll go and pause the video, see what you can do on your own. All right, hopefully, the very first thing that you did was you distributed the 7 to both terms inside the parentheses. And which property is that called when you multiply a number into both numbers? Distributive property. Very good. So 7 times 3x is 21x. And 7 times a negative 5? 35. Negative 35. And 4 times a negative 5 is a negative 1. Now, Mr. Starks, I thought you did an excellent job when I looked at your paper. I liked how you added a 35 to both sides. I really liked how you did that because you know these are additive inverses. They always add to 0. Okay? So right now I'm going to drop the what? I'm going to drop the 21x down right here, dropping it down. I'm setting it equal to 35 and a negative. It's like, I want you to think, in your world, this is when you have $35. This is when you spend $20. So when you're combining them, now you have what? 15. So sometimes people struggle with what? Adding or subtracting integers, right? Just think, that's money I have, this is money I don't. Okay? So now, at this point, you should have divided both sides by 21, and you get the value of 15 over 21, which reduces, if you divide this by 3, and you divide this by 3, so what? You divide this by 3, and divide this by 3, and I get the final answer of 5 over 7. So my final answer is 5/7. This is my exact answer. I want an exact answer. I do not want the decimal equivalent of 0.71428571428. I don't want this. Okay?
I'm sorry. Is that correct?
Yeah, that's what the decimal equivalent of 5/7 is. It just keeps going on forever. Okay? So, one second. You didn't believe I had it right? Well, which one? Where do you think I'm wrong? Oh, you know what? I bet your calculator rounds. I don't. Listen, there's a pattern here. Watch. Where does the pattern repeat? 0.71428. Uh-oh. Guess what? It repeats where? Right. Come on, board. We go. Right here.
Oh, that's not cool.
You see the pattern now?
Yes, sir.
So that's the repeating pattern of sevens. Okay? All right? So if you said, Mr. Mood, I bet you don't know what 2 sevens is. Well, yeah, it's the same pattern. It's just 2 sevens. This is 0.2857114, and then it repeats again. All right? So understand, sevens have a pattern. But I don't want that. I want an exact number of 5 sevens. Okay?
That's the answer.
That's the answer. 5 sevens. Now, at this point, we're going to look at this particular problem. Okay? And it says, Haley is planning to travel a total of 1,250 miles during a trip. Her car gets 30 miles per gallon on the highway. I'm going to highlight that. 30 miles per gallon on the highway. And it also gets 22 miles per gallon in the city. Now, if she travels, 1,000 miles on the highway, all right, we're going to find the total number of gallons of gasoline she will need for the entire trip. So we got to figure out how much gas is she going to need to buy to make sure she gets to her destination. So what I'd like you to do right now is I want you guys to write certain things down. I want you guys to write highway, okay, and I want you to write
Like on a journal or on that?
just on the paper, right there. Highway and city, right there. Highway and city. I'd like you to put the miles that she's going to be traveling on the highway. Okay, so we have the miles here. I want to know the miles she's going to be traveling in the city. And I also want to know the MPG, miles per gallon for the highway, and the miles per gallon for the city. So, using that information, figure out, if you were Haley, how many gallons would you have to purchase, round it to the nearest whole gallon, all right, for that trip. All right, if we look up here, how many highway miles does it say she's going to travel? 1,000 highway miles.
And then 250 city.
250 city. What's her miles per gallon on the highway?
33.
Miles per gallon
Oh,
city?
okay, yeah.
22. Does it say 30 or 33? That says 30 and 22. Okay. So right now, if we actually wanted to figure out the actual number of gallons, if this is the miles, and this is divided by the miles per gallon, you would divide 1,000 divided by 30, and that would give you the amount of gallons. If you take 250 miles and divide it by the miles per gallon, that will give you the number of gallons you're going to need in the city. So 1,000 divided by 30 is 33.3 repeating gallons. That's okay. And 250 divided by 22, all right, is going to be 11.36. I think that repeats, okay? So when you add those together, okay, you get about 44.7. But if, by the way, what you're going to have to do is you actually have to you want to make sure you put in 45, if I round to the nearest amount of gallons. If you would have put 44.7 or 44.6, I would have marked it wrong. But understand, would you agree, if you have 45 gallons, you are going to definitely get there. If you put 44 gallons, you're going to be like some of these kids who almost graduate. They get right up to the last week before graduation, and then they drop out.
Kids do that?
Okay?
Yeah.
Every year, they go from kindergarten to 12th grade, and there's like 2 weeks left, and they do something ridiculous, and I know it's recording. It's what happens every year. Hopefully you're not that guy.
Or they wait until the last week of
They
school.
wait till, or maybe if there's 1 month left to go. They get like 99% of the way through their,
How are you going to do that?
oh, it happens
You
every
live
year.
with your son.
I know that.
Like here it happens?
Let's watch that.
All right, so right now we're going to look at problem number 4 and problem number 6. Number 4 says the ratio of the measures of the sides of a triangle is a 3 by 4 by 6, and its perimeter, you can't see it, is what, 104 feet? Is that what it is? Okay. What I want you to understand, I'm going to draw a quick little triangle right here. Watch. This is not drawn to scale, so please don't shame me. This is not drawn to scale. But wait, right now, let's pretend we have a 3 to a 4 to a 6 ratio. Sure. Right there. So if I have a 3 to 4 to a 6 ratio, right now, what's the perimeter of this tiny little triangle? That would be 3 plus 6 plus 4, which is
13.
13. We don't want a perimeter of 13. We want a perimeter of 4. So watch this. We're going to put an X next to this, an X next to this, and an X next to this, because we're going to scale it up so that it becomes a 104. We're going to scale it up by X. So watch. If I have 3X plus 4X plus 6X, and I set it equal to 104, now you have 13X equals 104, and when you divide both sides by 13, you get 8. Hold on, that's not the answer. Well, watch what happens when you take this 8, and you plug it in there, and you plug it in there, and you plug it in there. What is 3 times 8?
24.
Boom, that's one of your sides. 24 feet. What's 4 times 8?
32. I mean,
32.
32.
32 feet. And last but not least, what is 6 times 8? 48. Guess what? Those are your 3 measurements right there. What's 24 plus 32 plus 48 actually added up to equal? 104. All right? So right now, what I'd like you guys to do, right now, go ahead and see if you guys can figure out 5, 6, and 7 on your own.
Right now?
Not right now, but for home. Good.
Oh, I was going to say.